this video, I would like to talk about the different work holding devices and the different tool holding devices. First, let's talk about work holding. The workpiece we're going to be working on today is just a piece of rectangular steel. We're going to drill a hole centered on it this way and 1 inch in from the end. So there's two ways to set things up on this machine. You can either set them up directly on the table. Then you'd have to use a T-slot with a stud in the groove on the table. And that would require you to use the clamp and one of these step blocks on the back side. When you're doing a setup like this, it's important to make sure that the back of the clamp is higher than the front of the clamp. Now you don't want it to be extremely high like that. You just want it to be a little bit higher. So if you held on to it like this on the material, just go 1 notch higher on the back side. That way there you're ensuring that this tip of the clamp is what's holding down the material. The other thing to be cautious of when you're doing this setup is to make sure that your hold down stud is closer to your material than it is to the step block. So if I was to tighten this all the way down, I know that this would be tightening right on my material. If I had my setup exaggerated the other way like this, I don't have as much holding force because now the stud is putting equal pressure here as it is here. So it's important to make sure that you have everything close to the stud. On a setup like this, if I was going to drill a hole all the way through here, this is not a good setup. I would end up drilling a hole right into my table. So typically you would have to put some kind of a spacer block underneath the part, whether it would be parallels or 1, 2, 3 blocks underneath there. 1 clamp would not be enough either for this. So I'd have to put up my part on parallels and probably use 2 clamps just so the material stays secure on the table. A better way to hold on to a part like this, you can use a work holding device called a vise. With a vise, it's the most familiar work holding device. Everybody has a vise probably at home in their garage. So as you open and close the vise, there already is ridges in the vise there that'll keep your workpiece above the bottom of the vise. So if you put your workpiece in there and close your vise, it'll sit right there on that little shelf. So this is probably the most used work holding device on a drill press. For this one here, you just close it by hand and you push down on the red handle, and it's actually a cam lock. That will secure the workpiece in the vise. Most typically, when you use a vise on holes under 1/2 inch in diameter, you don't have to clamp the vise down. Be careful though, because if this vise wants to rotate, it's going to come around and hit the operator. So if you're doing small holes in a vise, you don't have to tighten the vise down. What you have to do is make sure that the vise is all the way rotated up against the column, as close as you can get it. That way there, if the vise decides to rotate, it can only swing that short distance. It's not going to swing all the way around. So it is a perfectly safe setup to do holes under 1/2 inch in diameter without clamping the vise down. If you find yourself doing larger work, then you can line up these slots in the slots of the table and clamp the vise down. Use at least 2 clamps. To release the vise, you lift up on the red handle, open the jaws, and take out your workpiece. So let's talk a little bit about tool holding devices. The most common tool holding device is a drill chuck. A drill chuck, as you turn this collar, you can see the jaws are opening and closing, and these hold straight shank tools. Now when I'm talking about a straight shank tool, I'm talking about a standard drill bit where the shank of the drill is straight. That'll fit right up in the drill chuck. When you tighten a drill chuck, you need to use a chuck key. This is probably the biggest safety hazard on a drill press. Do not leave the chuck key in the chuck. While you're using the chuck key, make sure it is in your hand. This chuck key never leaves your hand until you're done using it and you're setting it down. Do not leave the chuck wrench or the chuck key in the chuck. So if you turn the chuck key to the left, it loosens the jaws. If you turn it to the right, it tightens the jaws. Tighten at least 2 of the holes. I like to tighten all three. There are 3 holes in there, let's use them all. That way there we know the drill is being held in there centered and securely. It won't slip in the jaws. Drill chucks can hold anything with a straight shank. The capacity of the chuck is listed on the chuck. Here it says 0 to 1/2 inch. That is how big the jaws go. It will open up to a 1/2 inch drill. The problem is, what happens if you need to drill a hole larger than a 1/2 inch? What I have here is a 51/64 drill, and it does not have a straight shank. It has a tapered shank. Inside this machine, there is actually a taper that's holding the drill chuck in there right now. To remove the drill chuck, I have to lower the quill, and I will then use a drift pin to remove the chuck. On some drill presses, you have to line up the slot with the spindle. The spindle is inside the quill. So you're going to rotate your spindle until you can see through that window. When you see through that window, you'll put your drift pin in. And tap it with a hammer. Now while you're tapping that, keep your hand on the drill chuck. You don't want the drill chuck to fall out and strike the table. So hang on to the drill chuck. Remove the drift key from the spindle and you're ready to put in another tool. So now this tool has a taper. The problem is the taper is smaller than the spindle. So to adjust to the different sizes of tapers, if you have to go from this size to this size, this is a number 3, this is a number 4 Jacobs taper, we need to put a sleeve on there. So this sleeve will adapt this tool from a 3 to a 4 taper. To put this in there, we have to line up the tang of the drill to the slot. And when that lines up, snap them together and they will hold. Same thing when you put it up in the machine. Make sure it is clean. You can then line this tang up with the machine. Once you get it lined up, you snap it in there. That is a self-holding taper. That won't come out unless you use the drift. Once again, if you remove the tool, you can use the drift. That's how you remove the tool. To remove the sleeve, you use the drift again. So those are the different tool holding devices that we use on the drill press. It's very important to keep those tapers clean. If these tapers become dirty, they become inaccurate. When you put them up in the machine, you're damaging the inside of the machine and you're damaging the sleeve. So keep your tapers clean. Same thing with your work holding devices and your machine table. It's very important to keep this clean. If you're doing a lot of drilling and you get a lot of chips on your table, you may have to stop and clean it up and then continue working.